All right, team, here is the game plan for today. Thanks again for focusing in and getting this crushed out while I am working with my little to make sure that her mouth is okay from her fall. So you are working today on an assignment called Cosmic Microwave Background Radiation for today, which is September 21st. So you should already have grabbed it from Notability. Looks like this, right? You've got it working in here and you're gonna work to fill this out today. And you can use this video, you can use the models around the room, or what I would recommend, a combination of both to make sure you get your full understanding and ability to kind of use the visuals. We've got kind of the first set is some observation questions, and then the second half is some forward thinking questions. So feel free to take a look at that video if you're just needing a little extra guidance. So I put in here a couple red statements just to remind you what you're thinking about while you're working on this by yourself within the classroom without me there. At this point, hopefully you've already read through the introductory paragraph just to get an idea of what this cosmic microwave background radiation is referring to. Remember, radiation is energy that can travel through space in waves. So what's so special about this microwave version? What are we noticing? And as you're reading, you're just highlighting it up, connecting ideas to our evidence question about the early universe. So the first part here, part number 1, I have created a balloon marked with a gamma wavelength. So remember on our chart here, we've got all kinds of different levels of energies. On the left side, you're going to see those radio waves all the way to the gamma waves or gamma rays over here on the right side. And that wavelength is different depending on the energy. So I just put a couple things on our first model. We've got the squiggly line, that's obviously the wave or the wavelength of energy. And then we've got 2 dots on here. And like I say in the directions, the 2 dots are representing 2 points or 2 objects in the universe. For example, could be 2 galaxies. So this is the model that we're using. And again, you see a couple around the room, but I'll model it in the video as well. So looking at number 2 and 3, what we want to do is start to inflate the balloon and expand it a little bit and make some observations about how that changes. So I'm just going to follow the directions here, again, using the models or watching me. So we're looking at how the wave changed from initial to now, and you've just got a quick circle and fill in the blank here. So go ahead and pause and take a look at how the wave looks different. Remember, wavelength, we're measuring that distance from crest to crest. So how does that wavelength look different from the beginning? And also our 2 points. They got really faint there as I kind of blew it up. So I'm going to go back real quick. So here's our initial, right? Our 2 points, and then our wave. So we're looking at that distance from crest to crest, that wavelength. How is that changing? So you can circle and fill in those blanks as you watch our first demo. Again, keeping an eye on that crest to crest. What's that distance like? And again, here, the 2 points. I'm just going to darken those in. Here's point 1 and point 2. Okay, so there's the first thing. Just observe how that changes. And number 3, if I were to continue to blow this up, what would we be noticing happening again to the wavelength? Right here. And the 2 points here. So that's thinking about number 2 and 3. And you can, of course, feel free to rewind and check that out again. Number 4, we want to do some actual data collection. So again, I'm going to get back to my original balloon. And I'm going to take notice that I want to draw how the wave looks from the initial point and also get a measurement. So I've got my ruler here, measuring in centimeters. I'm looking at 2 points. My first measurement here is going to be 2.5 centimeters. So on number 4, we're filling out this table. right? We've got the info here before inflation, draw out what that wave looks like, and record the centimeters here. Then I'll blow it up a little bit, look how it changed, record the centimeters, and again, the final. Okay, so that's what we're thinking about. So again, here's our initial. And our first measurement in centimeters is going to be 2.5. So I'm going to be measuring this point every single time from here to here. Okay, so that was 2.5 centimeters for that first distance. So I'm going to draw that in and record 2.5 centimeters in my chart. Now I'm going to draw it, inflate it halfway. See what that looks like. Draw it out. So again, here's our brand new look at our wavelength. Again, I'm going to measure these 2 points from here to here and see how that's changed when my balloon's been half inflated. So you can go ahead and draw how it looks different. We started at 2.5. Now we are at 7 centimeters. So again, I'm going to record that in my chart. Draw in how the wave visually looks different. And our final box here, number 4, is fully inflated. So I'm going to do that. Now the wave did get fairly faint, but I think you can still see it there running across the balloon. And again, I'm measuring now these 2 points, right? So I'm getting the ruler out, measuring these. So while I get the ruler, go ahead and draw that third view of the wavelength now that we are fully inflated. And I'm measuring again in centimeters. Same 2 points. Now I'm looking at 13.5 centimeters. So we went from 2.5 to 7 to 13.5, measuring that wavelength, right? The distance from one point to the next on the wave. And this is our fully inflated wavelength. So you should have a drawing and a measurement for each of those. So 5 and 6, with the balloon. 5 and 6 are thinking about you putting your diagram into a statement, right? So taking that visual and diagramming up top already, now we want to write out, well, what's the details? So we've got to describe here using data. So plug in some or all of those centimeters as you talk through what changed as the balloon changed. And then we've got a little prediction. And remember, there's no wrong prediction except an empty one. So I'm letting you know that we started with the deflated balloon as a gamma radiation, right? So we're wondering, as the balloon or the universe inflated, right, and we watched that wavelength change, if we started here at gamma, what might happen to our energy type? If gamma wavelength looks like this, well, how did the wavelength change? And maybe what energy could you connect to what we see today? And again, it's a predict question, but your answer, that line, should have one of these green names on it for the energy type. Okay? So I'm going to pause right here. You can work back or get done what you need to do. There's one more video on those last few questions if you feel like it'd be helpful for your completion of the assignment today. As always, message me with questions that you might have. Screenshots of where you're at are super helpful.